After checking the bike over, it was ready to go back to the client. Or was it? Hello, my name is Bob, and once again I'd like to welcome you to another episode on the White Dog Garage YouTube channel. For the last week or so I have been repairing this Suzuki GSXR 750 after it was involved in a crash. Yesterday, with the job finished, I took it for a short test ride. I went about 10 kilometres in total, about 6 miles. When I came back, I stopped the motorcycle in the drive and went to open the door to the workshop. When I came back, I just happened to notice that the temperature was slowly climbing on the temperature readout. And I sat there and watched it for a minute or two. It certainly had been operating at normal temperature on the road, and it probably every 30 seconds went up a degree. Where I thought the fan would have started, and I looked down and the fan hadn't started. And I thought, hello, I think I need to investigate this. And that's what I did. I'd pretty well worked out what was wrong yesterday, and last night I went on the internet just looking for parts. And as I go about these things, I like to just field the general question first, which is, cooling problems in a Suzuki GSXR. I was amazed at the number of questions that were asked about cooling problems in late model liquid cooled motorcycles. It's a problem that's not only in Suzuki but in all of them. And of course, as it goes in the internet, for any one question there's at least 25 answers, most of which are wrong. And I thought, maybe there's a video in this, and instead of just fixing this problem that I've got and pushing it out the door, I'd make a video about it. And that's what I'm going to show you now. So let's talk about the things that can go wrong with the cooling system. But let's start by actually looking at the components of the cooling system. I have a hastily drawn schematic here. We have the motor, and around the motor we have a water jacket. And then we have a pump, and that pumps coolant around the system. We have a radiator, heat exchanger in engineering terminology. We have a cooling fan, which sucks or blows air through the radiator. Normally pulls it through. Sometimes it can blow it through. We have a thermo switch, which can be on or off, which will turn the fan on for extra cooling or turn it off to reduce the cooling. We have a pressure relief valve. The whole cooling system is pressurized. If it gets too great, then the pressure release valve needs to release fluid. And then we have at the top of the motor usually a thermostat. And thermostat allows a slight flow when it is cold, when the motor is cold, and then fully opens when the motor is hot to allow the coolant to circulate. Problems relating to the cooling system can be summarised under the headings of coolant, exceeding maximum pressure, external and internal leaks, the coolant pump, the thermostat and the fan. So on the topic of coolant, please don't ever put water in your motorcycle cooling system. It does it no good at all. Proper coolant has a mixture of ethylene glycol and salts that buffer the system to a tight pH range, preventing corrosion, and this is super critical in alloy motorcycle motors. Overpressure is the pressure cap venting more coolant than normal, or a pipe or a radiator ruptures due to too much pressure. The causes are overheating due to very hot weather, hard slow going, coupled with blocked or damaged cooling fins in the radiator or failure of the cooling fan. The first two call for a break in travel to let it all cool off a bit. The third needs repair or replacement, and the fourth I will cover later. Physical blocking of the internal tubes of the radiator by sediment in the coolant is another cause. Here you can flush or replace the radiator or in some cases remove the top and bottom tanks and physically clear the sediment blockages in the down tubes. Another cause is head gasket failure or a crack forming, usually in the head, that allows combustion gases to leak into the cooling system, overheating the coolant, or just increasing the pressure in the system above the limit. One way to detect this is that if you, when the motor's cool of course, take off the radiator cap and with the engine going, you'll see bubbles coming up through the coolant. Solution is to find, repair or replace wherever the problem lies. The next possible cause is failure of the pressure cap to seal, and this can be either due to a perished rubber on the cap itself or the cap's spring losing tension. The quick solution here is just replace it. And another cause is the thermostat not opening. All you can do with the thermostat is replace it. External leaks are usually evidenced by a puddle of coolant under the bike or visible coolant on the motor, radiator or hoses. Causes here are ruptured coolant hoses or loose hose joints. The solution there is to replace the hoses or retighten the hose joints. Another possible cause is cracked or damaged radiator. Solution is to repair or replace. Another cause is gasket failure, and that can be either a head gasket or other gaskets associated with the cooling system. Solution again is to find, repair or replace. And finally, you could have a hole or crack in the motor. The holes in particular are usually caused by corrosion, and this corrosion gets eroded away by the flow of the coolant, and eventually it makes it to the outside. This is one of the reasons I say proper coolant, change when specified. Solution is to find, repair or replace. Internal leaks are usually evidenced by coolant in the engine oil. There'll be a milky colour or chocolate colour, light chocolate. What you sometimes see as well, depending on where the leak is, white smoke in the exhaust. You get white smoke first thing in the morning on a cold morning, which is just condensed water being evaporated off the exhaust system. If the motor warms up and the white smoke's still there, then that could be caused by a leaking head gasket, leaking coolant into the combustion chamber, which is then turned to steam and comes out the exhaust system as a white gas, which is essentially steam. The causes are head gasket failure. Go back looking for those bubbles in the coolant, not always present. Other gaskets in the motors, internal coolant passages failing, and of course my bugbear, the erosion of metal between internal coolant passages and the inside of the motor. That again comes when you don't replace the coolant regularly or you've just used water. Solution, of course, with all of these is to find, repair or replace. Failure of the coolant pump is usually evidenced by a pronounced rattle or bearing screech from the coolant pump or inefficient cooling, not explained by another reason. Causes are, well, it's often age and mileage related. It is essentially a bearing failure, that's the screeching or the rattle, but there's the possibility of a driveline failure. The impeller itself can decay over time. That's unlikely, but you can't always rule it out. The solution in all of them essentially is just to replace the coolant pump. Symptoms of thermostat failure are either the engine overheats due to it not opening, or it takes a long time to reach operating temperature, if ever, because it is stuck open. Obviously the cause is the thermostat's failed. It's either permanently closed or permanently open, and the only solution is to replace it. Fan failure, and that's the crux of this video, is evidenced by the fan not coming on when the motor passes operating temperature, usually in stop-start traffic or prolonged idling, as occurred here. Often there's enough airflow through the radiator on liquid-cooled motors when they are travelling that they don't need the fan. So the causes, no electrical power to the fan. There's a host of possibilities there: a blown fuse, a short circuit, a broken wire, a thermo switch that turns it on and off not working. And of course the other one is the fan motor itself has failed, and the solution is to find the fault and either repair or replace the defective item. So the problem we have here is that the fan isn't working, so I'm just going to show you a logical approach to finding out what the exact issue is. So the first thing we do is we look at the fuse. I'm using a circuit tester because it will show you a light. It's a bit easier than a multimeter, but you could use a multimeter. So you're going to look at the fuse first, and if you look here we see that the third one from the top on the left hand side is a 10 amp fuse for the fan. I've got the circuit tester attached to the negative terminal of the battery, and we're looking for power, so the light will light up when I find power. I touch the power side and there's nothing. That's not unusual. I'll try it with the key on. Lo and behold, the light's on. So try the other side of the fuse and the light's on, so we know that the fuse is good. Of course, if you don't have a circuit tester, you can pull the fuse out and inspect it. So if you look there, there's a little loop of metal. I don't know how well it can show up on the camera. Anyhow, the loop is intact. That's what you're looking for. If you do have a meter, it always pays to run a meter across, because sometimes if there's a fine break in there, it's not immediately obvious. But this one's good, so we'll put it back. The next area to check is the thermo switch that sits at the front of the radiator. Now this thermo switch should have power to the switch. When the radiator reaches a given temperature, the thermo switch turns on and power is conducted across the switch and onto the fan. And I will pull out the plug on the switch and we'll check for power being available to that plug. The switch has a clip at the back which you need to push in and then pull the plug out like so. Having pulled the plug out, I then use my probe to test for power, and I think you can see that there, the light's on, so we've got power to that thermo switch. Next thing I'll do is bridge the contacts across the plug, and I'm just doing this with a short piece of copper wire that I'm just forcing into the connectors. So there's the fan sitting there. I turn the ignition on, it's off and running. So in this case the problem lies with the thermal switch in the radiator, and that's what we'll be replacing. The thermo switch is screwed into the front of the left side radiator tank, and I used a 24mm spanner to undo it, making sure I supported the radiator at the same time. Coolant will flow out when the switch is removed, so I had a bucket handy to catch it. An O-ring is used to seal the thermo switch plug to the radiator, and I gave the one on the replacement switch a light coating of rubber grease before fitting it. Viewers will have probably noticed that I have removed the lower fairing and ducting on this bike to make the replacement easier, and there should be a link above that will take you to another video that I made on fairing removal. As part of this repair, I drained the old coolant and replaced it. Make sure you choose a coolant compatible with aluminium radiators. Because I left the ram tubes in place, I put together a funnel and a tube to make it easier to fill the radiator with the new coolant. The system holds about 2 to 2.5 litres of coolant, 2 to 3 quarts. If necessary, you could flush it through first, either with new coolant or, less expensively, clean water. The coolant in this bike looked to be in good condition, so I settled for just replacing it. With the system full of new coolant, but with the radiator cap still off, I started the bike and let it warm up to allow any trapped air to escape. I topped up with new coolant as required, and then refitted the radiator cap, topped up the overflow tank, as well as checking for any leaks. Finally, I check the system is holding temperature. Although I've not shown it here, I allow the bike to warm up completely. I then shut it off and allow it to cool down. I then check and, if required, top up the radiator and overflow tank levels.
We're all good. That's what I like. I hope you enjoyed this episode, and if you did, I'd welcome a thumbs up, and by all means, share it. Share it amongst your friends, share it amongst people who aren't your friends. It's all good. And if you haven't already subscribed, think about subscribing. It's easy. Just hit the subscribe bar down below. While you're there, don't forget to ding the bell so that you're reminded by YouTube next time a video on the White Dog Garage channel comes out. Thank you once again.
As bonus footage, I thought I might show the operation or testing of a thermo switch. I'm using the new switch for this, and I first taped a thermocouple sensor to the switch and ran the lead back to a meter that will register temperature. I then used a second meter to monitor resistance across the thermo switch terminals. I then immersed the thermo switch in a pan of water and heated the pan on a hot plate. This could be done more simply by merely using a thermometer in the water and a test light across the two terminals. The operation of these switches is based on the behaviour of a bimetallic bridge. This would be either a strip or a disc. The bridge consists of two different pieces of metal which are clamped together. As the two pieces of metal heat up, they expand at different rates, and that makes the strip bend or the disc invert. In the case of the strip, one end is connected to one terminal of the switch, and as it heats up it bends towards the second terminal, eventually bridging across the two terminals. In the case of the disc, it is inverted away from the two terminals, and when heated up it flips the inversion and makes contact or bridge across the two terminals. The configuration of the metals is chosen so that they will bridge the gap to the second terminal at about 80 degrees centigrade, 176 degrees Fahrenheit. Upon reaching the specified temperature, the circuit is completed and the fan turned on. Simple, eh? Watching the meters, as the temperature meter passes 79 degrees centigrade, 174 degrees Fahrenheit, the resistance across the terminal suddenly changes from infinite to less than an ohm, and that will mean the switch is now turned on and the connected fan will start to run. Pretty neat. Thanks for watching.